Hey guys, I am making a video over some of the practice problems that are due today because I've had several questions over this last problem, problem D, which of all of them, this was the hardest because you had to come up with the genotypes yourself. So let's go through this. So this problem, I don't know if you can read it, let me focus. All right, so this is the problem. It says, in humans, thick eyebrows are dominant to narrow, and separated are dominant to joined. Michael has a very thick unibrow and is worried his future children will as well. He is surprised that he even has one since his mother has narrow and separated eyebrows, just like his beautiful wife, Alexia. Alexia's dad has a unibrow. Okay, so they gave you this information. Um, so the cross is going to be between Michael and Alexia. And you have to figure out what Michael and Alexia's genotypes are. And the clues they give you is because they talk about what their parents were. Okay, so you have to think about what the traits they're looking at are, and then what they could possibly be because of that. All right, so like we start all dihybrids, we start with the traits. So we have thick and narrow is the first trait. So let's use T's. We have thick or dominant. Okay, then we'll do recessive T to narrow. That just means thin. Okay, and then we have separated are dominant to joined. So separated means you have two eyebrows, joined means you have a unibrow. I'm going to use A's because S's are not great, but I'm going to say capital A gives is dominant, that is separated. Okay, and then a joined is recessive. Okay, so we have to figure out what Michael's genotype is. No, I gotta refocus, sorry. Sorry. All right, so what is Michael's genotype? All right, the problem says Michael has a very thick, okay, unibrow. Okay. And is worried about his future. So for the thick part, we don't know if he's heterozygous for thickness or if he's homozygous dominant. We'll have to do a little bit more investigation. So his T's, we're not really sure, but his A's we can figure out because he has a unibrow. That means he has to be homozygous recessive because the unibrow or the joined brow is a recessive characteristic. His T's we're not sure about. He could be big T, or big T, little t. Both would give us thick. The problem tells us that he was surprised he has such a thick eyebrow because his mom has narrow eyebrows. All right, his mom has narrow eyebrows. So remember the classic homologous chromosomes genetics. We get one for each one of our genotypes. We get one of the letters for the genotype from mom and one of the letters from dad. If grandma, Michael's mom, has narrow eyebrows, that means she has to be little t, little t. So the only version of T that she can give Michael is recessive T, which means his dad had to give him the dominant T because he got thick eyebrows. He doesn't have thin eyebrows. So this has to be Michael's genotype. All right. We have to do the same thing. We have to do some thinking. We have to think about Alexia's genotype. All right. So we're going to do two different letters again. Alexia, let's read the problem. All right. She has narrow, separated eyebrows, just like his mom. Okay. So his wife and his mom have the same eyebrows. But it does tell you that Alexia's dad had a unibrow. Okay. So what that's telling you is that she's going to have to be heterozygous for the joined thing. Okay, we'll get to that in a second. So she has narrow eyebrows. So that means she has to be little t, little t. And then she has separated eyebrows, but her dad had a unibrow. So just like for Michael's genotype, for him to be a heterozygous here, Alexia is going to have to be a heterozygous here. She has the dominant letter, which is going to mean she has two eyebrows, but her father gave her a recessive A because he had a unibrow like her husband. So she's a carrier for the unibrow, right? So she could have a child with a unibrow, but she herself does not have one. All right, so that's probably the hardest part of this problem is just coming up with the genotypes. That's what everyone was asking about. I don't think the cross part you guys are having trouble with. But I'm just gonna do it anyway since I'm already here. So let's cross. Let's do this. All right, so right, we're gonna foil. So let's foil Michael. Let's foil Alexia. Okay, so we've made Michael's sperm and Alexia's eggs. So now we can, do the big square. Okay, let's do sperms. And then eggs. Oops, I wrote that one in the word spot. Okay, and then let's put them together. Keep the T's together and the A's together. Okay, so the different phenotypes that we could have thick, separated, thick, joined, narrow, separated, narrow, joined. So those are our different phenotypes. So to be thick and separated, that means you have to have one big T and one big A. We've got 1, 2, 3, 4. Right, so we have 4 out of 16 thick and separated. To be thick and joined, that means you're still going to have a big T, but now you're going to have a little a, or sorry, 2 little a's. So that one is here, here. I'll do checks. Keep track of that. Big T's, little a's. Okay, then down here. All right, so that's 4 out of 16. For narrow separated, narrow is recessive, so we're looking for little t's. Separated is big A's, is dominant. So little t's with big A's. So we got 2 here and 2 here. So that's 4 out of 16. And then narrow joined, I already know there should be 4 left, but I'm just going to do it anyway to keep track. So narrow is narrow is recessive. Joined is also recessive, so we're going to have little t, little t, little a, little a. So we got 1, 2, 3, 4. 4 out of 16. All right. Then it says, will Michael have children that look like him? What is the percent chance? Okay. What is the percent chance that Michael has a child with a thick joined unibrow? So this is number 4. It's the question. There's a 25% yes, he could. And there is a 25% chance. This is all breaks down to 1/4, 1/4, 1/4. Can reduce it. Yes, 25% chance. What is the most likely eyebrow phenotype of their offspring? Last question. What is the most likely eyebrow phenotype of their offspring? What is the likelihood? There is no likely phenotype. All have same chance. So all have a 25% chance. So there is no likely phenotype. All right, that's problem D.